In today's video, I want to talk a little bit about measures of variation. Now, there's a lot of vocabulary that goes along with this, as you can see, but anytime you have a variation in something, or anytime something varies, it's sort of how many different options are. If you have a variation of how many different types of flavors of soda that people like in class, that means there's a lot of different types. If there's not much of a variation, that means they're all pretty similar. But more variation means more spread out. Less variation means more similar, more close together. So if we look here, first off, a measure of variation is a measure that describes the distribution of a data set. So it's explaining how spread out, or how is the data distributed. Do we have a lot of numbers that are all over the board, that are way spread out, that are very, very different from each other? Or do we have a lot of numbers that are very similar, very close together? Some of the different measurements that we can look at. One is the range. And many of you have heard this one before, just like mean and median and mode from previous years. But the range is the difference between the greatest and the least value in a data set. Remember, difference means to do subtraction. So in order to find range, we're going to take the biggest number in our data set, we're going to subtract our smallest number from that, and that's our range. That tells us how spread out is the data. There are quartiles. Quartiles help us to divide data into 4 parts. Sounds like quarters, like a basketball game or a football game, or even a quarter like a dollar. Splits it up into 4 parts, and it helps us to sort of understand how the data is spread out and how they are similar and different from other pieces of data. The first quartile is the median of the lower half of the data. So once we find the median of the data, then we take a look at the lower half, and we decide what the middle part of that is, and that's what we call the first quartile. Now notice we don't have a second quartile, next it goes to third quartile. There's no need to do a second quartile because it's the middle, it's the very middle. Just like the end of the second quarter in a football game is halftime, it's the middle part of the game. The second quartile in a set of data is actually just the plain old median. So we don't have to have a special name for the second quartile. The third quartile then is the median of the upper half of the data. We don't have a fourth quartile because that's the very end, that's the highest value. So we don't need to worry about a second or a fourth, we just worry about the first and the third. And those parts are important because that helps us to understand the interquartile range. The interquartile range is the difference between the third quartile and the first quartile. Again, we see the word difference. Difference usually means, or I should say always means subtract. So anytime we're finding the difference, we're going to subtract the quartiles from each other. So let's take a look at what this would look like then as we move forward. Got a data set here for you, and our first example says to find the range, the first quartile, the median, the third quartile, and the interquartile range of the data. So let's take a look and see what that would look like. Let me get the smartboard going here. All right. So let's take a look. I've already put the data in order from least to greatest. We learned in the last couple lessons that in order to find median, we have to have the data in order from least to greatest. It's just a good idea that anytime you have a data set, put it in order from least to greatest because you got to do it to do these different types of measurements. So the first thing we're going to do is find the range. And the range is pretty simple. Remember, that's the difference between the highest value and the lowest value. And in this data set, the highest data value is 15. The lowest data value is 1. Very simple. 15 minus 1 is 14. That is our range. Probably the easiest one to do of these. The next thing it wants us to do is find the first quartile. Well, in order to find the first and third quartiles, we have to determine the halfway point. Because remember, the first quartile is the half or the middle of the first half of data. The third quartile is the middle of the second half of data. So before we can start this, we have to find the median. So I'm going to move along and find the median next. So here's what I can do. Just like I showed you guys in the previous video, you can underline, cross off however you do it, but you work your way from one end to the other until you get to the middle. So I've got 3 on each side. Now I've got 4 on each side. So therefore the number that's in the middle is 7. That's our median. Now, in order to do this, I like to put kind of a dotted line where the median is, because you want to make sure that when you're finding Q1 and Q3, which is the abbreviation for first quartile and third quartile, you do not want to include the median. So when we find this, we don't want to include the 7 in this case. So in order to find first quartile, or Q1, I'm going to find the middle of just this section of data here. Okay, remember, not including the 7. So I've got 1, 5, 6, and 6. So if I do the same process, I'm going to cross off the different directions so I can figure this out. You'll notice that I have 2 numbers in the middle. And just like when we did median, when you have 2 numbers that make up the middle, you add them together, which 5 plus 6 is 11, and then you divide by 2. So 11 divided by 2. 2 times 5 is 10. If I do my subtraction, I've got 1 left. And this is one thing that I've noticed that a lot of students struggle with at this point, because up until now, every time you've done division, you have remainders, but we don't do remainders anymore. If we have this situation where we still have a number down there, we put a decimal and a 0 and bring that down. And just like we said before, 2 times 5 is 10. And so I bring up my decimal, and my median of the first half, or my first quartile then, is 5 and 5/10. Sorry, this got kind of a little bit messy here, but there's our Q1. Now to find Q3, same process. I'm going to look at the second half of data, which is right here, and I'm going to do the same thing. I'm left with 2 in the middle. Whenever you have the 2 numbers, you add them together. And 8 plus 10 is 18. Divided by 2. Let me write this in a little different spot here. There we have room for our numbers. And the nice thing about this is we know that 2 times 9 is 18. So our Q3 then is 9. So if you look, if I put a dotted line now, I've already done it at the halfway point for the median, but I can also go back and put my dotted lines for my Q1, which is at 5.5 or 5 and 5/10. So that's directly between the 5 and the 6. If I put in my dotted line where the 9 would be, directly between the 8 and the 9, notice there's 1 and 5, 6 and 6, 8 and 8, 10 and 15. We've split this up into 4 different quarters, or 4 quartiles. Okay? 4 quartiles. The last thing we need to do, and I'm running out of room here, but I'll do my best, is we need to find the IQR, the interquartile range. And that's very simple. Interquartile range is the difference between the third quartile and the first quartile. Difference meaning subtraction. It's very simple. IQR is no different than doing Q3 minus Q1. So in this case, we're going to take Q3 of 9, and we're going to subtract 5 and 5/10. In order to do that, I need to fill in my place value with the decimal of 0. I'm going to have to borrow. 10 minus 5 is 5, 8 minus 5 is 3, bring my decimal straight down. So therefore, my IQR is 3 and 5/10. A lot of numbers there. Here's what all this stuff is telling me. The range, 14, tells me that the numbers are spread out between 14 numbers. There's 14 numbers between the highest and the lowest. Tells me how spread out they are. The median, just like it did before, tells me the very middle number. Q1 and Q3, Q1 tells me the middle of the first half of the data, the middle of the second half of the data for Q3. And the IQR tells me how far apart those 2 parts are. So it tells me what's the distance between Q1 and Q3. How far apart is the middle chunk, the middle half of the data? So that's what all those pieces of information are telling me. All right. A lot of different pieces of information. Just have to make sure you understand how to find each one. Range, biggest number minus the smallest. Median, find the middle number. Q1 and Q3, find the middle of the upper half of the data and the lower half of the data. And then lastly, the interquartile range, or the IQR, take the quartile 3 minus quartile 1. A lot of different numbers there, and that's what's going to help us make our box plot down the road. And that'll be for another video. All right, got another set of data here somewhere. There it is. bigger numbers here. We've got some bigger numbers, but we can work with it. I've already put them in order from least to greatest, like you should always do. But make sure that you have that so that we can move on from there. Once you have them all in order from least to greatest, we're going to again find the range, Q1, median, third quartile or Q3, and the interquartile range. So let's start. First thing I'm going to do is I'm going to find the range, which remember, range is pretty simple. Range is going to be, let me get my marker working here. And we've got some technical difficulties here. All right, well, we're going to get this going here shortly. All right, hopefully now we're in business. All right, hopefully I got this fixed now. If not, you'll have to bear with me, but I'm going to be writing on the computer, which makes it a little bit more difficult than writing on the smartboard. So we'll try this again. The first thing I want to look for is I want to find the range. So right off the bat, I'm going to subtract the smallest number from the largest number. Which would be 98 minus 51. And like I said, it's a little bit slower, a little bit more difficult to just write directly with the mouse. But if I do my subtraction, I come up with 8 minus 1 is 7, 9 minus 5 is 4. Now, right off the bat, here's why these numbers are important, because if you look at our last set of data, the range ended up being 14, meaning that the amount of numbers or the numbers that were between our highest and our lowest were only 14. Here, you notice that the numbers, there's 47 numbers between our highest and lowest. This tells me right off the bat that there's a much wider range of data. This data's more spread out. There's a higher number, there's a low number. So comparing the two sets of data, we would definitely have a bigger range for this set. All right, remember, next thing we want to find, if we are going to be doing this, we need to find the median. So if we're looking for the median, and I'll do my horrible writing here and try to make this work. But if we're looking for median, we're finding the middle number. We can start here, we can work our way across until we get to our middle number. Now we've got 1, 2, 3, 4, 5 on this side, 1, 2, 3, 4, 5 on this side. If I took one more of each, I would be left with no numbers. So here we go. We've got two numbers in the middle. And remember, we've got to take those two numbers, add them together. So we'll take 81 plus 82. If I do that, I get 3. And 8 plus 8 is 16. And then the last step then would be to divide 163 by 2. Now, some of you might already be thinking about what you know the answer is already, just based on some prior knowledge. If you're thinking in the terms of money, like what's between $81 and $82, you can actually kind of sort of skip this step. It makes it much easier for you to do. But if you're not thinking that way, let's just go ahead and do the division. I know that 8 times 2 is 16. I do my subtraction, it gives me 0. Bring down my 3. 2 times 1 is 2. That's the best I can do for that one for right now. But if I do my subtraction, I've only got 1. Put my decimal in, put a 0, drop that 0 down. 2 times 5 is 10. Do my subtraction. Whoop. I got 0. Bring my decimal straight up, and now my median is 81 and 5/10. Back to what I was talking about with the change. If you have $81 and $82, halfway between $81 and $82 is $81.50. Another way you can think about this, it maybe makes things go a little bit quicker for you, but hopefully that'll help you. So 81 and 82, 81.5 is going to be somewhere here in the middle. So I'm putting my dotted line. So now I'm looking for Q1, which is going to be my first quartile, dealing with this set of data right here. Now notice I am going to include my 81 because my median is actually 81.5, so I do want to include my 81 on this one. So let's start from each side, work our way to the middle, and again you'll notice two numbers in the middle. So for our Q1 we're going to take 62 plus 72, do the addition, 2 plus 2 is 4, 6 plus 7 I get 13. So if I take my 134 divided by 2, hand drawn with the mouse is hard. 6 times 2 is 12. I do my subtraction there, I end up with 1. Bring down my 4, and I know that 7 times 2 is 14. Do my subtraction, I have 0. So Q1 ends up being 67. So if I wouldn't put that, that would be directly here in the middle between these two. Next thing, if I want to find my Q3, I'm going to look at this set of data right here for my Q3. So I do the same thing. I cross off as I work my way into the middle. And you'll notice, again, recurring pattern here. We've got two numbers in the middle, 89, 95. So let's go ahead and add those two numbers together, 89 and 95. 9 plus 5 is 14. 8 plus 9 plus 1 is 18, so I have 184. Let's do 184 divided by 2. 2 times 9 is 18. Bring down my 4. 2 times 2 is 4. So therefore my Q3 is 92, which would fit somewhere directly in between those two numbers. So again, I've broken up my data into 4 different parts. The range tells me the spread of data from the biggest to the smallest, how far apart they are. The median tells me the direct middle. Q1, or first quartile, tells me the halfway point of the first set of the data, or the first quarter of it. The Q3 tells me the halfway point of the second part of the data, or the third quarter of it. And then there's one last thing I got to do, and I'm going to scroll down for this one. But I'll scroll down and do the IQR. And the IQR for this data, remember, is taking third quartile minus the first quartile to tell you how far apart the middle half of the data is spread. So 92 minus 67. Extend the page. Do my borrowing here. This becomes an 8. 12 minus 7 is 5. 8 minus 2, 6 is 2. So my IQR then becomes 25. Remember, a measure of variation is trying to tell me not what's the middle point, because we did the measure of center. That's the middle of the data. Now when I work on this stuff, this is trying to tell me what exactly is the spread of the data. How far apart are they? What are the numbers that kind of fall in between? So measure of center, measure of variation are very different. They're both very useful for us, but they're also both very different. As we mentioned before when I talked about the range, this set of data is much more spread out than the first set of data we looked at because their range is only 14. Now notice also with their Q1 and Q3, those are obviously bigger because we're dealing with bigger numbers. But let's see if the IQR is similar as well. Our first IQR we said was 3.5. So there's only 3.5 or 3 and 5/10 difference between the first half of the data and the second half, or in that middle chunk. In this set, again, bigger numbers, bigger spread. Notice as we scroll down here, we have a 25 IQR. So there's 25 is the variation, the spread between that middle half of the data. This data is going to be useful for us as we go ahead and do box plots, which I'll do in another video. But for now, just keep practicing your range, median, Q1, Q3, and IQR. If you have any questions, please stop in and see me. Again, as I say every day, I'm here before school, during lunch, after school. Stop in and get help. Otherwise, hopefully you'll learn something, and we'll see you guys later.